Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of Energy. After analyzing the calculation of heat demand for the biomass project, let's finish this part of the course with the forecast of electrical demand.
When sizing an energy supply solution, the first and foremost design parameter to determine is the expected demand, specifically the heat demand and the electricity demand. There are two types of electricity loads, DC or AC. DC is the direct current, which flows only in one direction. For example, the one supplied by a battery cell in a torch or flashlight. When steady and not pulsating, a direct current is often called a continuous current. DC loads are mainly used for small appliances and off-grid applications. AC means alternating current. It is the form in which electric power is transported and delivered to businesses and residences. It is the most widely used form of electrical energy to run appliances, machinery, electric lamps, or telecom devices. This video is about AC loads. The calculation of electricity demand can be done by considering different application scenarios. Consumption from a utility grid. Self-generation, also known as self-consumption facilities. Off-grid systems. And CHP systems. For systems connected to the grid, basically you need to calculate the peak demand that will influence the supply contract with the utility, the energy consumed along the year for calculating the expenses and project feasibility. For self-consumption facilities and off-grid systems, accurate calculations are needed for sizing the generation of electricity and, if applicable, the storage systems. For centralized heat and power or CHP systems, both heat and electricity demand must be calculated. The video about heat demand will help you to deal with this part of energy demand. This video focuses on CHP systems for providing energy services to a single building or for a set of buildings. For example, a public building like a hospital or a sports center, or a smart network with domestic buildings or with a combination of households and public buildings. The questions we will address are: how can we predict the electricity consumption for a given service that includes households and public buildings? How can the electricity consumption change along the day and along the year? How can we calculate the energy to be provided and the power to be installed? Obviously, there are different approaches. The first decision you must make is the accuracy you need for your project. The higher the accuracy, the greater the difficulty of the calculations. When sizing the power system, the goal is to supply all the energy that is needed when needed. Then, you may be tempted to oversize the system. The bigger, the better. However, you should keep in mind that oversizing electricity sources decreases the efficiency and the economic viability of power systems. Therefore, you need a certain degree of accuracy to ensure the realisticness of your design. Ideally, a site's electricity demand profile should explore the daily variation in electricity demand with at least hourly resolution. This is helpful to identify the peak power demand over a daily cycle. Seasonal variations along 1 year period. This is helpful to assess the type of renewable energy supply sources that can be considered.
Okay, but on what parameters does the electricity demand depend?
Electricity is mainly consumed for lighting, communications, motor-based applications, or heat-generating appliances. Therefore, you need to know the number of electricity-consuming devices, their electrical power, and the number of hours, in a daily, monthly, or yearly period, they are consuming electricity. For CHP systems, obviously, heat is not generated consuming electricity. Another important parameter is the use given to the building. For example, a single-family house, an apartment block, a school, an office or an office building, a hospital, or a sports center. Because different types of building have different consumption profiles. For example, a sports center, an office, or a school will mainly consume electricity during the opening hours. Instead, a hospital will consume electricity during the whole day, and residential buildings mainly in the afternoon. The next question is, how changes the electricity consumption along the day and along the year? The first step is to understand that electricity demand changes continuously. Then, it is not enough to calculate the overall energy consumed during a year for sizing power systems. Electricity demand depends, for instance, on climate conditions when heating and cooling systems are provided by equipment consuming electricity. For our CHP system, there can be two scenarios. Cooling is provided by a heating and cooling network, or cooling is provided by air cooling electrical systems because only heat is provided by the CHP system. Only in the second scenario, the electricity consumption will be very sensitive to climate conditions. Regarding hourly consumption, it depends on the utilization of the building and the utilization of electricity consuming devices during the day. From this data, peaks and daily demand are used for sizing power systems. The last question is, how can we calculate the energy to be provided and the power to be installed?
You can use a spreadsheet and add the type of equipment or appliance, the power consumed, and the hour per day that is consuming electricity. With this, you can calculate overall daily consumptions. Doing the same calculations hour per hour, you can estimate the hourly consumption profile in a day. If consumption is expected to change along the year, you can repeat the same calculations for every month.
Wrapping up.
Electricity consumption or energy consumption depends on the equipment consuming electricity, their power, and the time they are consuming electricity. Using a spreadsheet, you can easily calculate the daily consumption curves, which depend on the utilization of the building and the climate conditions if air conditioning equipment consume electricity. Curves peak will allow you to calculate the power to be installed.